25 people. The second one.
So thank you for saying record. I'm recording.
So anyway,
I'm sorry,
it's been a
well
attended and very vibrant discussion. So it's been interesting, but several of you are attending. So thank you.
Yes, yes. And if Ben and Carol, so Carol, I don't know if you'd like to go first. I'd love for you to share your screen. I don't know if you can see on the bottom, it says like share.
Share. Oh, yeah, got it. Okay, and I have my e-portfolio all done, and I have it up. I just need to bear with me.
Mm-hmm.
I feel kind of lame that I don't know how to do this, but that's kind of where I am.
So apparently someone doesn't know how to share documents and maybe record on Zoom.
Oh, I see what it did. I very carefully, hang on. Is Ben ready?
I'm happy to go if you want.
Ben, if you could go first,
okay.
I will be able to go second. I have it up. I just can't figure out how to do this.
No problem.
Thanks.
Yeah, so I'm not sure what all you'd like me to say about it. But
yeah,
I can kind of talk
exactly what you have if you'd like to share it.
Yeah, hopefully you're seeing it now.
Yeah, it looks great.
So, yeah, my students are primarily future elementary teachers, and then a handful of future middle school science teachers. So I'm teaching science to a group that is largely science phobic. So it's actually a lot of fun. They're a good group to work with. And this is the first of a series of 3 to 4 classes they take from the science education department. So I'm kind of their intro point. Now, let's see, advice I give my students. A key thing in this class is it's all about collaborative learning. So it's about being there and engaging with your group and working together to generate knowledge. So you got to show up. And then I'm doing something kind of interesting with the quizzes and tests this year where they take the quiz on their own online. Basically every class there's like a little quiz afterwards. And they do it. So now I've changed it just a little bit, I think since I wrote this even. But what they do on their own, it's worth a half a point a question. And then in class, they come back and in their group, they take the exact same assessment again, where it's worth 1 point a question, but they work together. They all answer the same way. And then there's an extra credit opportunity if for every question they tell me what they think the most common wrong answer was from the individual quizzes. So start to think about like, well, what thinking would lead you down these paths? So I've been doing that this semester and I've really enjoyed it. It's been really good. So my advice to students is you're going to be working together. You got to do some legwork on your own, try things on your own, but it's really all about being there to help your group. Let's see, the impacts on our SLOs. I don't know how interesting it is to talk about my SLOs.
I think a lot of faculty, in my experience, have trouble kind of with the SLOs. I think this group might be a little bit different, but it's not always apparent. So I learned about student learning objectives through the course redesign people.
Mm-hmm.
And so if you want to talk about how the learning objectives you have maybe are enhanced or you're targeting them with the course redesign.
Yeah, so let's see. So I have, I was able to draw on a couple resources. One, the curriculum that I'm implementing, the Next Gen Pet curriculum, has a bunch of language like this on the website that I can draw from for the different modules that you can use. So I was able to draw on that. I'm having to meet the requirements of our liberal studies majors who are future elementary teachers. So I know, like, here's the SLO, basically the things they say they need, and here's the things the curriculum says they could do. So it was, it made it a lot easier to come up with this list of things I say I'm going to do. But right, it's like, what are the outcomes? What are the things you want them to be able to do? So it's not, none of these are to know, hopefully. Yeah. The things that they can like identify or predict. It's some action verb that they'll be able to do once they've completed a unit. Yeah. I'm happy to talk more about it if people have questions or.
Right now, I think what you did was great. And if you can kind of talk a little bit more about the end part, how did you address the accessibility, and then what did you say about yourself?
Yeah. So for accessibility, one of the key things here. Blackboard Ally is something we're using, which is it Ally or Access? I thought in my head it was Access, but I wrote Ally. They're accessibility tools. So each of the, basically everything on Blackboard gets an accessibility rating, or nearly everything. And so I'm working with folks on campus and one of my learning assistants to bring up the accessibility rating of all of the different things. So for some of them, that means taking a PDF and regenerating it in Word, differently, or taking it into Adobe Acrobat Pro and doctoring it up, and it's labeling figures and stuff like that to bring up the accessibility of everything we have on Blackboard is a big part of it. For affordability, it's nice in this class we don't have a book because there's no lecture or things to memorize. It's all kind of activity based, but there are then these activity modules that walk them through them where they write everything down. It's something that's consumed throughout the semester. So there's no really expensive book, but they've got roughly $90 worth of activity guides to buy. So I wish that were lower, but I don't see a way around it. All the online quizzes and simulations and all that's all free, which is nice. And then I also use Clickers, which has a cost, but lots of classes or a number of classes across campus use them, and the hope is that that's something they use throughout their degree, so it's not kind of specific to this class. Thinking about diversity, one of the, two things. One, I often draw on students' lived experiences to think about making sense of some scientific ideas. So what have you experienced in your life to see this, which hopefully allows people to talk, or students from all different backgrounds to talk about their lives and bring their lived experiences into the classroom. And the use of learning assistants has been associated with significant improvements for students from traditionally marginalized groups. So I use learning assistants in my classroom, which also help hopefully facilitate these discussions. So there's that.
Yeah, I'm curious. So this is really great, and you just have a little bit about yourself, and I think that is pretty much more than what they were looking for. Carol, would you be able to share? Want to take a stab at it? Thank you, Ben.
Yeah, absolutely.
Oh, I think that you're muted. Oh, yes. Yes.
All right. So, and now I'm not muted, and you guys can all see my screen?
Yep.
All right, so skip over the stage 1 stuff because we already finished that. So I will have a lot of things that contrast nicely with Ben's because we're in a very different kind of a situation. If you look through my student characteristics here, Biology 101L is our life science lab course that we have at Cal State Fullerton, and we are the largest CSU, so I always surprise people by telling them, oh, I have 22 sections of lab every semester, and I have 546 students this semester, and that doesn't even get into the lecture course. The lecture course is an entirely different issue. But one of the things that I wanted to emphasize here on the student characteristics is all 8 colleges at Fullerton have students that take this course. And we have this semester 46 different majors. So they're across a wide range of interests and what their academic goals are. We usually have a handful of students that are from the NSM college, the Natural Science and Mathematics, but they tend to be more on the math student side than on one of the lab science. So there's 2 main courses that students take to hit the B3 objective at Fullerton. They take Biology 101L or they take Geology 101L. And they like Geology 101L because it involves field trips to go get muddy. And Biology 101L, they kind of look at that and be like, bio, ugh. So we're trying to change that. And one of the things that I'm really looking at is you can see here when we're looking at students who can take 101L either at the same time they're taking the lecture or after. And there's some interesting critical thinking choices that students make. So they take 101L very early on in their academic career. So this 35 to 45% here that already took 101 may have taken it their freshman year, and now they're a graduating senior. So they have very thoroughly wiped out any biology knowledge in the intervening time. So we have a huge range of backgrounds, a huge range of interests, and a huge range of how much they remember whatever it is they might have learned in lecture. So one of the things that I'm looking at having the hybrid lab project do, and Kambiz and I talked earlier this month about how he's used Labster on this, is to use some of the online pre-lab work that they would be doing in intervening weeks in the hybrid format to kind of bring students up to a common level. So that's one of the things I wanted to try to emphasize here. Advice I give my students. So this is advice I give my about dozen TAs who are graduate students who are actually teaching this course for them to pass along to their students. But the key things here are to get students realizing that there are 3 types of assignments. So just showing up in lab isn't going to get you a passing grade. So make sure you do stuff outside of lab. And this other thing here is we have a lot of metacognition built into these assignments, especially on the synthesis assignments. And students get a little leery about having to answer questions that don't have a right answer. And so we want to get them, I mean, to give you an idea, last spring I had to report 2 students to the Dean of Students office because they copied each other's reflections. I mean, really, come on, it's a reflection, guys. It doesn't matter what you write, don't copy each other. So we spend a lot of time getting students comfortable with there's not a right answer, make sure you do all the assignments, here's how to do things efficiently. And kind of what I'm hoping for down here, I sort of point at it a little bit. A lot of our students, because it's general ed, and they're not like, Ben has the luxury of all of his students have a common career goal. Mine don't. They're all over the place. And so we want them to try seeing that even though this is a science class and you're not going to be a scientist, there are still skills that you can develop. And so that's one of the things that I was trying to get at down here with team building, because we have some activities that they're doing by themselves, some that they're doing just with a partner, and then some that they're doing in small groups. And so letting them know that they're going to still be working on those team building skills with something. So here's where I contrast very nicely with Ben's well-written objectives. So the general ed objectives aren't written in a great way. So you see there's a whole bunch of these understand objectives, and that's a really good example of how not to write an objective, because how are you going to evaluate understanding? And I see, Beth, you're cracking me up because I can see you going.
So that's why I wanted you guys to share your SLOs. I have a really hard time with these, and I think a lot of faculty do. So I really appreciate you guys taking the time to do this.
And these are not SLOs that I have necessarily written. There's a lot of them that I want to rewrite, but my department chair is very leery about trying to change GE things that go across the university. So I just deal with these, and then we kind of have our silent SLOs that we really use for the course. But these are the official ones. Since I was putting this out on Merlot, I figured I wouldn't put our secret ones out there. So understanding is a really weak verb to use because it's not giving you any active verb. How does a student demonstrate understanding? Do they have to diagram the process of scientific inquiry? Do they have to perform experiments and demonstrate use of the appropriate set of steps? Those kind of things would be better objectives, but these are what we have. And for the hybrid course, what we're really looking at on the hybrid labs is we are completely up against our facilities limitations. We can't have any more courses, and we have more students that want to take this. So the hybrid project is trying to figure out how to leverage the in-class portion in a better way so we can get more students through it. And so the SLOs that I'm really focused on for the hybrid labs are doing two things. One is, how can I take out those pieces that students can do online, both collaboratively and by themselves, like formulating hypotheses, coming up with an experimental design, doing all the data analysis. All of those things are very easy to port onto an online platform, as opposed to having them go in and do the activity. I can have them do a virtual lab that involves working with a microscope, for example, and that can work on the second goal, which is getting them to the point where they all have a common baseline. But I want them to also go into a lab and try implementing those skills that they've developed online, so that you're working with an actual microscope and you can see, oh, well, I have to do this to put the slide in the right spot. So we're trying to kind of use the SLOs here to evaluate where the hybrid labs are in terms of student success and bringing them up to that common level. So that's kind of what I talked about down here. And what I don't have yet, but I've been working on, is going through Lasso, because Ben gave us that great introduction to it, and trying to see if there is a good, relevant assessment tool out there that somebody else has already developed, because I don't have the $1 million grant to develop one myself. And I haven't found a good one. What I've seen is there's a lot that's related to students that are going into some kind of science, but there's not for just general education science. So I am viewing that as a potential project that I can go apply for grants for the future, not now. So one of the things that we're going to do that's going to be kind of interesting is we're going to be comparing the SOQ scores and comments that students give in the in-person lab versus the hybrid lab, and see if we can not only improve student performance, but have a little bit better student satisfaction, because maybe it'll fit better into their lives. We're going to see how that all works. That's not what we've seen in the lecture class that has hybrid labs, but we'll see or that has hybrid structure, but we'll see what happens. So I have a whole lot down here on accessibility. We regularly have students with pretty severe physical disabilities that are trying to take labs. So for example, about a year ago, I had to figure out how to take a biology lab that's all about making observations and make it accessible to a student who has been completely blind since birth. So that was kind of interesting. And this coming semester, I'm going to have a student who has such severe physical disabilities that he has not one but two assistants to help him. So pretty significant proportion of inability to do our regular activities. And what I'm hoping is that some of these virtual labs that I can make accessible, they will improve the experience of the course for these students. If they're really not able to do our traditional kinds of activities, but I can make an equivalent experience that's far more accessible to them online, that's going to be a bonus for the hybrid. And affordability, we have a...
Can I just ask real quick, what kinds of special tools are there out? I don't know enough about accessibility and the tools that are out there to make
so having
blind students be able to visualize, even a virtual lab thing. I mean, are there monitors that display three-dimensional information that they can feel, or?
So a lot of what we did for the blind student, there were two things. One is modeling clay to give them the ability to actually feel things. We also put a little bit of money into getting some 3D models. Like we have 3D models of both a plant cell and an animal cell, where the different organelles have different feelings to them, so they can feel, here's what a mitochondrion feels like. We also have our DSS group on campus that can put forth labels in Braille, so we can have different things on the lab in the classroom labeled with Braille. The big thing that online does for blind students and for other kinds of visually impaired students or students with physical disabilities who have difficulty interacting with things is screen reader technology, where if you have the appropriate descriptions in there, like Ben was talking about, making sure you have all of those accessibility things done for images. If you have all of that done, a student can sit down with their screen reader technology and get all of that given to them in a way that they can't get in the same kind of an environment in lab.
But text, transferring text is very different from transferring
images. Content. You're not going to be able to transfer images to somebody who's a blind student. That's just not something that they can do. I had a very interesting conversation. I had a student who was blind who took both the lecture and the lab, and she's a psychology major, so she was really interested in how we were making things accessible. And I asked her this question. We were talking about phylogenetic trees, which is totally a visual representation. And she said, "You've done really well at explaining how this structure shows evolutionary relationships." She said, "I have an image in my head. I have no idea if that image matches the image you're showing to everybody else." And I thought that was a really interesting way to describe it. She's got an image in her head. I have no idea what it looks like. She doesn't really know what the image that I'm showing everybody else looks like, but she was my top performer in my lecture, so she clearly understood the concepts. So it doesn't necessarily matter if that physical representation is accurately transmitted to that student, as long as they get the concept. Why do you want students to be able to look at this physical representation? And it's not always easy to figure it out. Like when we're looking, one of the things we do in our cells lab is we want students to be identifying cells based on the characteristics they can see. So that's where we used our 3D model to have students essentially be feeling a cell. Even though they're not using a microscope, they're still getting to identify cells based on the characteristics they can see. It's an interesting challenge.
I think haptic feedback technology may offer some interesting options there.
There's definitely a lot of interesting options. It becomes a cost benefit thing.
Yeah.
I have one severely visually impaired student every 3 semesters or so. And so the amount of money that I can afford to put into kind of the bleeding edge technologies that are out there. But we've also come a really long way just in the last 5 or 6 years in having these technologies available. So that is out there. It's not necessarily, what we've been doing is trying to make things accessible in a way that fits in our financial realities.
Makes sense.
So on to finance, we have a lab manual that students use for their in-class activities, and it's custom. So we have it at about a $30 a semester price point, and we want to try to keep our costs around that same price point for our hybrid lab students. And the goal there is we want students to be able to choose the lab format that fits best in their schedule, rather than saying, oh, this one's cheaper than that one. So we don't want them making a financial decision. We want them making a scheduling decision. And so one of the things that I'm doing for virtual labs, we evaluated Labster and looked at it, and we could make it fit. They'd work with me to get it close to this price point for the pilot. But what I'm trying to look at is not what's going to be a good price point for the pilot, but if the pilot goes well, what would be a good price point for the full implementation. And so we're really looking at more of the freely available or low cost options for virtual labs. And they don't have all of the really fancy 3D modeling, VR, AR kind of things going on, but it gives me a lot of power to be able to use an HHMI biointeractive case study where the students don't have to put any money towards it. And I can package that up in a way that's going to work for our curriculum. So we aren't totally eliminating all of the fancy whiz-bang technology. We just got a makerspace on campus, so we're trying to see if we can maybe leverage that. But anytime I go and talk to people on campus that have those kind of technological resources available, and I say, well, would you be able to handle 545 students coming through a semester? They get a panic look on their face. So even though we have some of that, if I had a smaller enrollment, it might be possible, but it's not looking like it's a realistic option for us for the size class that we have to deal with. So that's kind of where we are. And I'm trying to wrap up so that we can actually get to the speaker. Diversity, big thing I always tell my students is we're at the Cal State system. We get diversity automatically. And I always kind of contrast that with my postdoc was at Iowa State University, where they were really happy when they had 8% that weren't white. And I'm like, I came from California. I've never been in this environment before. So I try to get my students to see that there's value in the fact that their peers aren't the same and that we have diversity in every classroom. So we've kind of got that good, doing a pretty good job on that. And the big thing that we've tried to do with our assignments is have a mix of different kinds of assignments so that it's not just one kind of assessment. And then I've got all of my stuff in here. I finally put a picture in here. I hate it, but it's my official CSU picture, so I've got it in there. The big thing, and I'll wrap this up, is in lab, in contrast to a lecture, we really want students to be doing something. And that's where we're really viewing the hybrid lab as an opportunity to have the point in time when the students come into that lab classroom, they don't have to sit and listen to a lecture from their instructor. They can be doing something right away. They will have done all of that pre-work. It's kind of taking the whole flipped model and applying it to a lab. And
yeah, thank you. Yeah, I love it. Thank you guys so much for presenting some really good examples of ePortfolio Section 2, Stage 2s. These are perfect. This is exactly what I, as faculty, go in and I look for. How are they being applied? What are the classes they're in? And who's the instructor? So very, very helpful. We'll probably bother Carol and Ben again, because I know there's a lot of conversation going on. Even the speaker is like, there's a good conversation going on, don't interrupt it. So we do have a speaker today. Mariya Mariya, I don't know how to pronounce your last name without butchering it. Mariya, I've seen some of her work. So she's an OIE fellow here on Fresno State campus. She works in the Kremen School of Education. And she's done a lot of work on incorporating technology into teaching and learning. And so I'd like to present Mariya. Are you there? Maybe not.
I think you're muted.
Me?
No, Mariya's mute.
Oh, Mariya, are you muted? Oh, let me see.
Can you unmute her?
Yeah, maybe.
Oh, no, it actually shows that it's fine.
She's not muted, but her voice was really low. So I heard her speak, but...
Oh, I kind of hear you.
Can you hear me now?
Yes.
Oh, yes. Okay.
Right. So if I speak like this, is this fine?
Yes.
Can everyone hear me?
It's still a little low, but I can hear you.
All right, I'll try to be louder.
Oh, that's good.
Yeah. All right. Okay. So let me jump on it. All right. So let me share my screen because I have slides. All right. So you should be seeing the slide right now, yes?
Yes.
And let me start it as a presentation mode. All right. So I am an assistant professor of research and statistics in the Department of Curriculum and Instruction here at CSU Fresno. I'm also an OIE faculty fellow, which is Office of Institutional Effectiveness. And as part of my OIE fellowship, I've been focusing on our discovery program. Our discovery program is essentially Center for Faculty Excellence provides professional development training to selected faculty on how to integrate tablets into teaching their courses. This training usually happens starting from January or February. They have 5 meetings during the spring semester. Each meeting is about 2 hours. And then they have Summer Institute, which is 40 hours full week of training. And they cover various aspects of how to teach with technology. They touch base a little bit on problem-based learning, so they do touch some pedagogical aspect as well as technological aspect. Part of it, I was doing, I do not want to call it an evaluation, I'd rather call it more exploration. But essentially, as part of the team, I administered a survey focusing on faculty's knowledge, self-efficacy, or their confidence about teaching with technology, and attitudes to faculty before the beginning of the professional development, so before the very first time they met, and at the very end. I will mostly focus on this piece. However, there have been other pieces as well, and I will also touch base a little bit on the follow-up piece as well, right? So I'm not presenting any theoretical framework for the sake of time, so I'm just jumping straight into methods and then results. I focused on, this presentation focuses on cohort 4 faculty, which went through the professional development in 2016-2017 academic year, and then they taught their discovery or tablet integrated classes during 2017-2018. As I mentioned, it used pre-post design around the professional development, which was received in spring-summer 2017. There were a total of 83 participants. 44 of them were discovery faculty, so those who signed up and went through the training. And I also integrated faculty who never participated in discovery as a control group. They completed a set of measures, all of which are focused on knowledge, self-efficacy, and attitudes. In terms of knowledge, they were asked to self-evaluate themselves in terms of mobile technology knowledge. For example, I can learn to use mobile technology in my teaching easily. Mobile technology integration into content knowledge, so whether faculty are able to think about how to apply technology in their specific course, because this faculty came from very diverse backgrounds in terms of departments. In terms of attitudes, faculty provided their perceptions of the ease of use of technology, so it's very technology-based questions. As an example of item is, it's easy to make technology do what I want it to do, as well as their perceptions of usefulness of technology. For example, using mobile technology would enable me to teach more effectively. They also were asked about mobile technology resistance for using technology in teaching, as well as attitudes towards teaching with mobile technology and attitudes towards learning with mobile technology. And finally, they were asked a few questions focusing on mobile technology self-efficacy. Self-efficacy is belief in one's capability to perform specific tasks successfully. So an example of item was, I'm confident with my abilities in selecting appropriate apps for teaching with mobile technology. All the scales were previously validated, previously developed, and either adopted or adapted for the purposes of this work. And faculty completed same instruments, again, before the intervention, and then, or professional development, and then after the professional development. In this specific work, I used their initial responses to create groups or unique profiles of faculty based on their knowledge, self-efficacy, and attitudes, using two-stage cluster analysis. So the results were as follows. And this might look a little bit busy, but let me explain it. So my results showed that there were 5 groups of faculty, or 5 clusters, all right? For example, cluster 1 or group 1, and we can see it's dotted line, so this is the group number 1. Each circle represents where they self-reported themselves on each of these scales. So you can see mobile technology, MT stands for mobile technology knowledge, mobile technology integration, mobile technology self-efficacy, perception of ease of use and usefulness, attitudes towards teaching and learning, and resistance. So as you can see, cluster 1 or group 1 scored very low on all of these indicators and very high on resistance. So essentially, I call them uninformed non-adapters. These are faculty who do not possess high mobile technology knowledge. They do not possess high self-efficacy towards teaching with technology, but their perceptions towards using technology for teaching and learning is also very low, as well as their resistance. Cluster number 2 or group 2 scored relatively low on knowledge towards mobile technology as well as mobile technology integration. They also reported relatively low self-efficacy and perception of ease of use. So this faculty were, essentially they did not have enough knowledge for using mobile technology, but you can see that they were very open-minded towards mobile technology because they scored relatively high on perception of their usefulness, as well as attitudes towards teaching and learning, and their resistance was moderately low.
Masha?
Yeah?
There's a question. Are these the responses after the professional development?
These are the responses before professional development. So these are the responses that, all right, these are the responses that faculty provided before they engaged in any professional development. And these are the responses of both discovery as well as control. So this faculty were essentially equated at that point, right? Sorry, I do not know how to access the chat window while I'm in the presentation mode. So yes, if someone asks any question, please just voice it up. That would be the most helpful. All right. So group number 3 and group number 4, they were very interesting. You can see that group number 3 and group number 4, they reported relatively high knowledge and ease of use and self-efficacy, right? But then one of these groups, group number 3, reported relatively low usefulness. They had relatively low attitudes towards teaching and learning, and moderate level of resistance. But group number 4 reported relatively high, like they believed in technology essentially compared to group number 3. And so I called group number 3 skeptics. This is the group that had knowledge towards technology, but they did not see utility of the use of technology in teaching and learning. Whereas group number 4 were believers. They had relatively high knowledge, and they also had relatively high, like they believed in technology. Finally, the final group is group number 5. And you can see that this group scored very high on all of the positive indicators and very low on the resistance. So essentially, these are confident enthusiasts, right? Something that I found very interesting was that, and you can see that I pointed out the number of faculty in each group, that uninformed non-adopters were 8, all of them were 8 control faculty. So these are faculty who would not even consider participating in discovery training, right? And discovery training is something that faculty self-nominate themselves. So it's not assigned to faculty, but faculty actually sign up to participate. And just to disclose everything, there are also benefits for participating in this training, in that faculty receive a tablet, like a very good piece of technology that they can keep, and that the assumption is that this is the technology that faculty would be using when they would be teaching the course, as well as professional development funds. Open-minded dreamers, those who had low knowledge but relatively high perceptions of usefulness and positive attitudes, you can see that the split was there were both control and discovery faculty in this group, as well as for skeptics, those who possessed high knowledge but reported low attitudes towards teaching and learning with technology. They also had relatively equal split. Believers, that's the group number 4, double line, had 8 control and 18 discovery faculty in it, and confident enthusiasts had 7 control faculty and 6 discovery faculty. So you can make some assumptions, and these are no more than assumptions, that potentially these are the control faculty who are so confident about technology that they potentially already integrating technology into their classes, and they just kind of do not care, or they have other commitments, which is why they have not yet signed up for discovery training, right? So next, I looked at each of these groups, except for the uninformed non-adopters, because this group only included control faculty, so they did not participate in the professional development. But then I looked at each of this group at the discovery subgroup only, to examine where specifically the discovery professional development had any effects on their knowledge, attitudes, and self-efficacy. Before that, couple other points. Uninformed non-adopters, as I mentioned, included control faculty only. This cluster consisted of significantly more full professors than faculty of other ranks. And this faculty on average taught at the university significantly longer, on average 25 years compared to faculty in all other groups. Open-minded dreamers, cluster 2, that's the cluster who had relatively low knowledge but relatively high positive attitudes. Consisted of more lecturers than assistant professors. Believers, that's the group that had relatively high knowledge and relatively high attitudes. Consisted of significantly more intervention faculty than control faculty, and of more males than females. And in general, on average, cluster 1 and 2, so uninformed non-adopters and open-minded dreamers, were more mature than faculty in other groups, right? But cluster 2 had the largest variation in age. Standard deviation was higher than in any other group. This implies that while they are, but there essentially this implied that in the open-minded dreamers group, there were faculty who were younger and less younger. All right, so then I looked at changes in knowledge, self-efficacy, and attitudes among discovery faculty. So this is pre to post changes. For group 2, open-minded dreamers, so those faculty who reported relatively low knowledge and relatively high attitudes. You can see that I bold-faced those scales on which there were significant differences. So this group of faculty reported much higher or significantly higher mobile technology integration into their content knowledge as a result of discovery training, as well as their attitudes towards teaching and learning improved as well. And their mobile technology self-efficacy as a result of this professional development also increased. All right, so let's look at group number 3. Group number 3 was skeptics. Skeptics were the ones who were relatively high on knowledge, but relatively low on attitudes. You can see that they did improve or did increase on their perception of usefulness of use of mobile technology in classrooms as a result of participating in discovery, as well as they improved in their attitudes towards teaching with mobile technology. So there were positive effects of the intervention or of the professional development on them. Group number 4, believers, this group scored relatively high on knowledge and relatively high on attitudes. As a result of discovery, professional development, they increased their self-reported mobile technology knowledge, as well as attitudes towards teaching and learning and self-efficacy. And these were 7-point scales. So you can see that they were scoring relatively high, but they, like majority of them on average, reported they were agreeing or strongly agreeing with the statements on these scales. Finally, group number 5 were confident enthusiasts. This was the group who already scored very high on all indicators except for resistance, and resistance was low. And you can see, essentially, they were already scoring at the ceiling. You can see for self-efficacy, all of them reported that they strongly agreed, that they're very confident about using technology in teaching, and there were no significant changes. So you can see some numbers change, but these were not significant changes. So as I mentioned, I will also touch a little bit on the second part. So what I also did after professional development, I followed up and I actually went into classrooms and administered survey to students of faculty who went through the training and who taught discovery classes. These results they're preliminary. I haven't yet put my hands up to my elbows in this data, but I have some preliminary results to share. So these data were collected in April and May 2018. There were 570 students who completed this survey. They came from 11 courses or 13 sections taught by 7 faculty members. So they completed either online version of paper-based survey, whatever their instructor agreed to. So it was all up to the instructor. Corey Kovan, she is now a full-time researcher at OIE, but she was a student assistant during the last school year, and she was our master's student in the Department of Psychology. She helped me a lot with this project, so I acknowledge her name here. There were also data from 241 control students. So these are students who came from who were taught by the faculty who never participated in discovery professional development. So these were not just non-discovery classrooms, but these were also faculty who never went through discovery training, neither during the cohort 4, nor cohort 3, 2, or 1, like ever. And this data came from fall 2017. So it was kind of like a pilot study that they did before going larger in spring 2018. And during fall 2017, I also had 88 Discovery students who completed survey as well. So students also completed a batch of surveys, but their surveys will focus more on engagement, specifically behavioral engagement, emotional engagement, cognitive engagement, agentic engagement during classes. I think you all but probably understand very well behavioral, emotional, cognitive. Agentic is essentially like taking a lead. Like if I do not understand something, I will go and reach out to professor. Like I have an agency, all right? It also included a couple scales from the self-determination theory, or from scales that focused on intrinsic motivation, such as intrinsic interest and enjoyment, perceived competence in the class, sense of academic identity. This is the scale that I developed in my previous work. So they completed this one, as well as they reported on faculty's frequency of the use of faculty can go through the training and then they can say nominally on the paper that yes, I'm teaching Discovery course, but they may not really frequently use technology. So I feel like asking students about the extent to which faculty is using mobile technology in their classroom provided some additional validity, instead of compared to faculty saying, yes, I use technology frequently, maybe because they do, maybe because of social bias, right? Social desirability bias. And there were a few scales focusing on pedagogy of the instructor. So whether the instructor used online self-directed learning, online collaborative learning, and constructivism pedagogy. So what I found was there were differences in pedagogy used by faculty who went through Discovery and who were control, as reported by students. Specifically, Discovery students reported that their classes used more of constructivism pedagogy, online self-directed learning, and online collaborative learning. Frequency of use of mobile technology on its own was related to student engagement. So when I just look at frequency as a predictor of student behavioral, emotional, cognitive, and agentic engagement, the more faculty use technology, the higher engagement was. But when I included pedagogy into the model, into the regression model, it was pedagogy that predicted student engagement. So this made me think that potentially technology provides affordances of implementing student-centered pedagogies, but it's pedagogy that really is related to student engagement rather than technology per se. Someone told me, I myself went through Discovery program. I was cohort 3, and we had a conversation, like you can even have a pen or a pencil and teach with a pen or pencil. It's just a tool. Same technology, it's just a tool, but it's the way how you use it, it's the pedagogy behind it that can really drive differences in how students learn and how they engage. Any questions?
Thank you guys so much. So I wanted Masha to share some of her work because I think it really highlights the importance of faculty development and supporting faculty to use technology and to understand the pedagogy, the importance of pedagogy in implementing technology. It's not just technology alone. And Masha's great at answering questions. I have some, and I know that probably Camby's has at least one. So I'm curious if you guys want to throw out some questions to her, it would be great to have a discussion.
So I think the faculty stuff that you were doing is very interesting. It seems like that kind of data could be used to target certain types of faculty for picking up and implementing some novel technology and tools. Is that something, like, would you be able to make the data available to everybody and is there even a way for us to find faculty throughout the CSU that are maybe primed for adoption of different types of technologies?
Very good question. Two questions. To address the first part of the question, I prepared the faculty piece. I prepared a report which was shared with Office of Institutional Effectiveness, Center for Faculty Excellence, and then it went like higher up, shared by the directors of those two departments. In that report, I did suggest recommendations, you know, that essentially knowing that there is this variability in faculty, it's possible to aim at specific either groups or specific things, for example, emphasize more pedagogy rather than the use of technology, or emphasizing the use of technology in addition to pedagogy. I myself do not create discovery professional development, but as a result of this work, they were informed, and I really hope that they will implement changes based on this work. In terms of the second part of your question, I am Beth, I'm not sure, like, who would be a good person for this kind of contact, because, you know, I'm an assistant professor in the Department of Curriculum and Instruction, so I'm not quite sure whether I have access to those faculty who like really eager, but I think that the Center for Faculty Excellence would be a very good place to go and either ask them, or and I'm not sure whether you're in CSU Fresno, but a lot of faculty just go through Center for Faculty Excellence and offer their own professional development or seminars or talks. So that could be one other way to reach out to those faculty.
So one of the things that the course redesign with technology, or I think the CSU and just education struggles with overall, is sustainability. So you might develop some pedagogy and some really amazing use of technology to achieve learning objectives, but just because you develop it doesn't necessarily mean that it's propagated through the system. And so we have some very effective uses of technology. So Camby's has been awarded one of the faculty leadership positions of the CSU, which we love, because of some of his amazing work. But how do you get others to do that? And so I think that what Camby's is saying is, yeah, you know, we've seen a lot of really good work, but how do we help that work pass on to others? And that's not something we've done very successfully as a system so far. So I think that your work speaks to that. And I'm not sure if we can keep in the back of our minds over this year of LIT, how to institutionalize our work and sustain the work and get more adopters. But I think Masha's work is really important in kind of considering how to do that. So I don't know, Masha, if you have some suggestions on that.
I'm not sure. I think like this conversation definitely came up earlier in terms of there are faculty who adopt Discovery and then they teach every semester for many years. Some of Discovery cohort number 1 faculty are still teaching Discovery courses. But there are also faculty who teach one course and then they stop. I think it's also important to look at case by case at the sustainability, because, for example, in my case, I taught it only once as a Discovery course. And the reason is when I typically, and it's very like logistics related. Typically, I am scheduled to teach in a computer lab. Our computer labs in the School of Education, they have student-centered environment. So students sit in round tables of 6. They sit in front of computers, and I have touch screen. So the main screen is touch screen, as well as there are at least 4 other screens around the room. Students can connect to those projectors, the side projectors. But when I was teaching Discovery course, I was placed in a non-computer lab room. And over that semester, I had so many technological issues. I had to call tech support every other class that I taught. I either was not able to start the system, or I wasn't able to connect to the system. And so I actually still use Discovery like Pedagogy, but I prefer to be in a computer lab. So formally, I cannot claim it to be a Discovery course because I am worried that I would be placed again in a non-computer lab classroom, and it would be it would have non-positive effects on my teaching as well as on students' learning. So you see, not everyone is in such situation, but this is just one example of how, like, you cannot just say like there is no sustainability. You need to really look at reasons why.
I know that we're over the hour. Thank you guys for staying on for a couple of extra minutes. I think that Masha has some great other publications out there. She mentioned the Global. I wanted you maybe to come back and talk about the high school where they collaborated together online to be different nations and share water. I think that was pretty amazing. But thank Masha for coming. As always, yeah, I need to look at that data and stare at it for a while longer. That was really great. And also, I just want to plug that following up, we have stage 3 portfolio not due anytime soon. It's due in February, and we'll have a prep webinar to prep for that in January. So after today, nothing is due for some time. There's a smart sheet that's going to go out to get updates. And so that will go out after, or maybe Ashley sent it out at 1, so you might have gotten it already. Next web meeting, we have, I don't know how to say their name properly, Vin Nguyen and Tommy Dang from Texas Tech. They're doing a lot of VR, AR with Unity, and several of our faculty are using Unity to create experiences for their students. We'll also talk a little bit about data collection measures, which I think Masha gave us a really good sample of how to use data. And I'm just going to say goodbye, and we hope that Ashley feels better. So Masha, thank you so much again. Thank you, Carol and Ben, for sharing your e-portfolios, and have a great weekend.
Thank you, everyone. Bye.
Thank you.